Welcome to YQ Academy Core Java Interview Questions and Answers. 1. Explain restrictions on using enum. 1. Enum declaration. Enum declarations must start with the enum keyword followed by the name of the enumeration. The enumeration name should be a valid Java identifier and cannot be a reserved keyword. 2. Enum constants. Enum constants are the predefined values of an enumeration. They are declared as static and final by default. Enum constants should be declared in uppercase letters and should be unique within the enumeration. 3. Enum body. The body of an enum can contain variables, methods, constructors, and additional enum constants. However, the enum constants must be declared at the beginning of the enum body. 4. Inheritance. Enumerations in Java cannot be directly extended or subclassed. They implicitly extend the Java lang enum class, which means they cannot extend any other class. However, an enum can implement interface. 5. Instance creation. Enum instances are created implicitly by the Java runtime when the enumeration constants are defined. Enum instances cannot be created explicitly using the new keyword. 6. Comparison and ordering. Enum constants can be compared using the equality operator equal. The order of enum constants is determined by their declaration order. 7. Switch statements. Enumerations can be used in switch statements. Each case in the switch statement corresponds to one of the enum constants. 8. Enum methods. Enumerations can have methods, allowing for additional behavior to be associated with each constant value. However, enum methods cannot be overridden or defined as abstract. 9. Serialization. Enumerations in Java are serializable by default, which means they can be easily stored and transmitted. The serialization mechanism takes care of preserving the enumeration constants and their values. 2. Explain about field hiding in Java. Field hiding occurs when a subclass declares a field with the same name as a field in its superclass. This results in the subclass field hiding the superclass field. When a field in a subclass has the same name as a field in its superclass, the subclass field shadows the superclass field. This means that when accessing the field from the subclass field is used instead of the superclass field. Here's an example to illustrate field hiding. In this example, the subclass declares a field named value, which hides the value field in the superclass. Inside the display method of subclass, when we access value, it refers to the field in the subclass which is 20. To access the value field of the superclass, we use the super keyword. 3. Explain about varargs in Java. Varargs, short for variable arguments, is a feature introduced in Java 5 that allows a method to accept a variable number of arguments of the same type. It provides a convenient way to pass an arbitrary number of values to a method without explicitly creating an array. The syntax for declaring varargs in Java is to use 3 dots after the type of the last parameter in the method signature. Here's an example. 4. Explain where variables are created in memory. Variables are created in memory based on their scope and type. The memory allocation for variables depends on whether they are primitive types or reference types. 1. Primitive type variables. Local variables of primitive types are created on the stack memory. Instance variables of primitive types are created on the heap memory as part of the object they belong to. 2. Reference type variables. Local variables of reference types objects are created on the stack memory, similar to primitive types. However, the actual objects that the reference variables point to are created on the heap memory. Instance variables of reference types are also created on the heap memory as part of the object they belong to. 5. Difference between stack memory and heap memory. 1. Stack memory. It is used for storing local variables and method call information. Each thread in a Java program has its own stack memory. Local variables are created on the stack when a method is invoked and removed when the method completes execution. Information about method calls, such as return addresses and method parameters, is stored on the stack. 2. Heap memory. It is used for storing objects and their instance variables. All objects in Java are allocated on the heap memory. When an object is created using the new keyword, memory is allocated on the heap to store the object's data and its instance variables. Instance variables are created as part of the object they belong to and are stored on the heap memory. 6. Can we use switch statements with strings? Yes, starting from Java 7, you can use the switch statement with string expressions. Prior to Java 7, switch statements were limited to numeric types byte, shut, int, char, and enumeration types. When using switch with string, the switch expression is compared to each case label using the equals method of the string class. The matching case block is executed if the expression matches the case label. 7. In Java, how do we copy objects? 1. Shallow copy. A shallow copy creates a new object that references the same memory locations as the original object. In other words, the new object is a copy of the references, not the actual data. Shallow copying can be achieved by using the equal operator or by invoking the clone method if the class implements the clonable interface. However, for complex objects, a shallow copy may result in unexpected behavior since changes to the copied object may affect the original object. 2. Deep copy. A deep copy creates a new object and recursively copies all the data within the object, including n-nested objects. This ensures that the copied object is completely independent of the original object. Deep copying can be achieved by implementing custom copy methods or serialization/deserialization. Custom copy methods involve creating a new object and explicitly copying each field, while serialization/deserialization involves converting the object to a byte stream and then reconstructing it as a new object. Here's an example of deep copying using serialization/deserialization. In the above example, the deep copy method takes an object and performs a deep copy using serialization/deserialization. The person class implements the serializable interface to enable serialization. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.